All right, well, welcome to the Hudson Institute. I'm Brian Clark. I'm a senior fellow here at Hudson, and I'm the director of the Center for Defense Concepts and Technology here at Hudson Institute. And we are very lucky today to have a great panel to talk about one of the top areas that the Department of Defense is trying to improve in, which is munitions manufacture, munitions production. This discussion today follows on to a report that we released here at Hudson about 2 months ago now, talking about ending self-imposed scarcity, which offers a new plan for how do you expand U.S. Munitions production by tapping into commercial sources of equipment as well as commercial manufacturing capabilities. And our panelists today will be able to hear to talk a little bit about that and what they're doing in their companies to try to improve the scale as well as the adaptability of our munitions, primarily through propulsion. We found in our research that propulsion, both jet propulsion and rocket propulsion, are one of the areas where the DoD has the most trouble in terms of getting to the kind of scale it needs, as well as offering options to be able to build more affordable weapons that have the flexibility to adapt to battlefield conditions. So we're going to focus on propulsion today in this discussion, and we have a great panel for that, as I said. So I'll go through them here going from, I guess, your left to your right. Anel Crespo is here from L3 Harris, the Aerojet Rocketdyne part of L3 Harris, where he's the Vice President of Operation Engineering. And then we've got next to him, Tim Furman, Colonel, U.S. Air Force, who was the former senior military leader for adaptive weapons in the U.S. Air Force's PEO for Weapons, Program Executive Officer for Weapons. And Tim is getting ready to retire now, but we've been able to get lucky enough to have him come and talk a little bit about what the government needs today and how it's pursuing adaptive weapons through some of programs like the Air Force is doing. And then next to him, we got Eric Hostetler, who's the CEO and founder for Volund Industries. Did I say that correctly?
Manufacturing, yes.
Oh, and which is a jet engine manufacturing company, which is offering new opportunities for scalable and adaptive, less expensive jet engines. Next to him is Gordon Lopresti from Northrop Grumman, where he is the Senior Director for Propulsion Systems and Controls, so working in the propulsion part of the company that used to be Orbital ATK, if you're following that. And on the very end there, we've got Ben Nicholson, who's the Chief Growth Officer of Ursa Major, which does additive manufacturing of rocket engines. So a great span of interest here when it comes to weapons propulsion. And I want to thank you all for being here today. Co-moderating this discussion with me will be my colleague, Nadia Shadlow, who's a senior fellow here at Hudson, and she is joining us remotely because she's very important and doing lots of fancy things outside of DC. So thank you, Nadia.
I had a family commitment away. Thank you.
All right, so to start with, I'm interested in each of your thoughts on kind of the big question, which is why is the DoD, why has the Pentagon had such difficulty being able to scale munitions manufacturing, and to what degree is propulsion a roadblock there, and to what degree does it need to be a roadblock? Because I think it's perceived as this challenge, but maybe it's one that we've sort of imposed upon ourselves. So Anel, if you want to start off. Great to have you here.
Yeah, and again, pleasure, and thank you for having me. Propulsion is a capital-intensive business, and as such, there has to be a strategy to be consistently feeding the machine. I call it the machine, the big manufacturing industry in the United States. And I think for the past few decades, you alluded to it, I think the priority hasn't been there.
Right.
So obviously we were producing propulsion, both in liquid and solid propellant, but maybe not at the quantities of the forecasts that are coming now, right? So high demand for both liquid and solid. We're adapting quickly, and I think the partnership in the United States between government, DoD, and industry is actually our biggest asset. History has proven that, and I think we're about to prove it again.
Right, right. And we'll talk a little bit more about how we are going to turn the corner, basically, on how do we get to that scale. So Tim, what do you think?
I think with anything propulsion, any of the ornaments that you put on a weapon, the value proposition just has to be there. Yeah. And it's not just an industry value proposition. Like the investors from the DoD also have to see that there's an executable path that comes with a planning profile that you can actually make this happen. And so that has to be navigated through many different offices, many different personalities that actually believe in it.
Right.
getting those personalities, decision makers, to really see the opportunity that exists in the industrial base and kind of how the industrial base is changing, especially what the changes I've seen in the solid rocket motor area. It's been pretty fascinating, and you kind of see the burgeoning effects of that happening also within turbine engine areas. Lowering some barriers, I think, is probably the biggest thing, whether it's test qualification or just getting more suppliers involved.
Right. Yeah, so Eric, in terms of jet turbine manufacturing, I think the number of suppliers involved has been one of the issues, right? I think the Williams engine has been basically used in every missile that we've built over the last decade, but clearly we need a greater diversity of sources. So, but what do you think the reasons are that we just haven't?
At least on the manufacturing side, you see everything about a propulsion system is exquisite. The engineering is exquisite. The engineers are hard to find. The materials are exquisite. They're difficult to work with. The number of foundries that can make the type of castings we need to do this are exquisite. And because things like these Inconels, the Mars, the Haynes, all these types of alloys are so difficult to work with, they're uncommon in most consumer goods. They haven't had that pressure from the consumer market to develop efficiencies and build automation, build a lot of the ways to move quicker to drive costs down that we've seen in circuit boards and machining and sheet metal composites and almost every other area. So, how do we build efficiencies? I think with some of these exquisite processes and materials, is going to be key to unlocking scale, unlocking cost efficiencies.
Just as a quick follow-up, do you find that the money coming in from the venture world or the PE world is helping to alleviate that and offer the ability to fund those kinds of, I guess, improvements so that you do get the experience of working with these materials, or just the scale?
I don't know that has yet, but I've been very encouraged to see that there are a lot of venture-backed foundries opening up. There are a lot of venture-backed manufacturing technologies that are being funded. Even last week at Reindustrialized, we see a lot of these interests. So I'm hopeful that we will see the path to scale open up there.
Right.
And Brian, could I just add?
Yeah, I was going to ask you, Nadia. Yeah.
Yeah. So I mean, in the commercial space and the commercial space sector, and this, the enormous growth in that area. I mean, how is that impacting this overall space? And this panel today, would it have looked different 15 years ago? In looking at the commercial space sector and opportunities for scale through that. Maybe, several of the panelists could comment on that.
Good point. Yeah. So Gordon, do you want to both take on what's the source of the roadblocks that you see? Because you guys have obviously been in this business for a long time, and then to Nadia's point, as the advent of commercial sectors that didn't exist before, it helped at all.
Sure. Yeah. So it's piggybacking a little bit on what Eric said. Some products, as everybody can imagine, gain overwhelmingly, that the DoD uses, gain overwhelmingly from investments in the commercial industry, things like processors, sensors, and those types of things. Maybe there's a little bit more synergy from the standpoint of the process side of things, but when you're talking about components, when you're talking about the products themselves, you see a lot more synergy with things like processors, sensors, those types of things. SRMs, if I shift the conversation a little bit to SRMs, are a little bit more unique and only have a few uses, generally defense-related or space exploration-related. So the technologies, the processes, the products really benefit almost exclusively from the investments in those particular markets. So there's a couple of principles that we have to maybe transition to or adhere to if we're going to be able to maximize that economy of scale, to be able to leverage what is a significantly less robust investment purse, versus the trillions of dollars that goes into digital investments and microchips and things like that.
Yep. So Ben, you guys do additive manufacturing for rocket engines for a lot of different uses. So I assume that you see that as a path to scale, and I imagine there's probably synergies to the space industry as well? Or?
Yeah, no, it's a great question. I mean, so there's a couple of things that you address. So I'll get to additive because that is a hallmark of what URSA does. I think your first question is to why are we in the predicament? And it's kind of simple economics. For the last 20 years, 25 years, DoD hasn't invested in magazine depth. They've been obviously consumed by war and terror and other things that happened during that time period. So magazine depths were at a sufficient level. I'll use the word sufficient. And that's obviously been exposed with a lot of things that are going on in the world that we're all well aware of. It's very difficult to devote capital and cost and funds. I was on appropriations for a number of years to just refilling the magazine constantly when you have got to modernize at the same time. And so I think that's the why. Then your question about why is propulsion so hard? Well, because it's hard. It's only rocket science, okay? And propulsion is definitely not cheap. We heard that, and that is exactly right. So when we look at additive manufacturing or printing, what it gives you is essentially complexity for free. You can do a lot up front, you can iterate, you can get to your design, and we can design, build, test within 30 days. And that's unheard of for high-end propulsion, whether it be liquid or solid. At URSA, that's our hallmark. We say fly faster. So we can do that in 30 days. We went from a clean sheet design to design, build, test to flying solid rocket motors within 6 months with the Army and with RTX. And that had not been done before through an additive way. It's not the panacea. Additive is not the way you're going to scale to thousands, but it is going to save you some upfront. And I think that's an important point. Last point, and I'll see the mic. The other reason that propulsion is hard is the traditional rubric with defense contracting has been good, fast, or cheap, and you can only have two. I would argue today we got to find ways to do all three, and that is very, very hard.
Right. So just to kind of follow up really quick, so you mentioned the idea that additive may not be the way to solve scale. You may not be able to build weapons at scale that way. But it does help with this issue of adaptability. So how do I figure out what the sweet spot is in terms of performance, scale, time to market?
It does, and I think the other thing that's necessary here is that one of the answers to like SRMs, and you heard this, is, oh, we'll add more entrants, but then you're all stressing the same supply base, and we're gonna end up in the same spot. So one of the things that additive does bring is an orthogonal way to look at how you might produce something. And it definitely stresses the qualification regime. Wait, this is a new way to do things. New alloys. I had no idea you could print the kind of alloys that we can. It's amazing science, but we're definitely at the edge of the material science there.
Right. Yeah, so Tim, you did a lot of work in terms of modular weapons with what was going on with ERAM and with Franklin, the ETV, the Enterprise Test Vehicle. To what degree can we think of propulsion as a modular component of a weapon, or does it really need to be treated differently because it's going to be, it has to be customized to the particular weapon itself? Can we think of it as just another way of modularizing weapons design?
I think you can. The government has to be okay with qualifying multiple sources. If the cost associated with doing that is palatable enough, then that's great. If we see a long-term ability to do that and industry sees long-term or longer-term promise in that, then I think it's doable. Whether it's turbine, whether it's solid rocket motors, the big thing for, I think, the government right now, what we want to be able to do is we want to have insight into interfaces and standardized interfaces. So what we don't necessarily like is engine control units that are like competitive advantage. That to me, I don't view that necessarily as competitive advantage. I view everything that goes on behind that is like what makes that company extremely special. So standardized interfaces that can be shared with larger supplier bases that would help incite suppliers that we can't necessarily see right now that might be pretty interested in getting involved. And so we wouldn't necessarily stress, my hypothesis is you wouldn't necessarily stress those same suppliers. Other suppliers would see an opportunity. They would see themselves in that market space.
Right. Yeah, good point. Nadia, I'm going to turn to you.
Yeah, I mean, Tim, you made an important point. Government has to be able to qualify multiple sources. So how far are we from that happening? Do you see opportunities to really drive in that direction over the next year? Do you see, not to put you on the spot, but your closest coming out of DoD, opportunities for real changes in the next year?
do, Nadi. I do see opportunities that exist because I don't see any other way to solve the flexible force problem set. So if we're really talking about flexible force and the ability to surge, to stress one particular supplier and facilitize that one supplier, that one system integrator, that is not the alternative. That is today's kind of business model. I think that there is opportunity. I think there's narratives around this. I think there's enough research around this. And now I mean, what I'm seeing is you see new disruptors entering into the space on the turbine engine side, certainly on the SRM side. And I think that is showing a level of confidence that I would never speak for the Secretary of the Air Force or certainly for SecDef on where the next dollar or penny is going to go, but there is certainly interest. And I think the corporations are feeling that. I think they're sensing it as well.
So,
Thanks.
So to follow up on that, looking at, like Eric, what you guys do with turbine engines at Volund, there are other companies probably coming into that space. But as you mentioned, it's a difficult. There's probably a limited number of people that can really do that kind of work. Do you see a way to make it so that turbine engine production can be more commoditized, or make it so that it doesn't require as much exquisite manufacturing or skill?
Yeah, and I think there's a few different ways to attack it. I think flexibility and requirements on the government side, if they can, understand that, if there's a plus or minus 20% on the performance side, that allows, this much faster of a development cycle, this much faster of a production lead time. I think that's one of the key things. I think the other part of it is just going to be able to flip the script a little bit and allow integrators to develop a system around an existing propulsion system versus getting your system requirements, distilling that down into propulsion requirements, then pushing those out. The characterization lead time of a new propulsion system when you guys go to integrate it into something can be very, very long. And I think, flipping that script, having something that resembles a COTS engine, whether it's solid fuel or air breathing, allows some of the flexibility, allows that modularity. It unlocks all of that.
Right. So Anil, the Aerojet Rocketdyne builds a lot of solid rocket motors. Do you guys think of that as being a sort of a modular, commoditized component, or do you really think of them as being bespoke and attached to a particular kind of weapon?
No, it's certainly a module or a commodity, right? We see ourselves as a merchant supplier of propulsion, right? That's how we see ourselves, and our strategy is based on that principle. We react to both. There are both forces, right? And I think that's the dilemma here. Sometimes the weapon requirement comes down to something very specific. Right. Well, you shall design and test, validate, and produce something very specific. Right. That works until you need to scale very fast, right?
Right.
So now we're at that inflection point. What we do in terms of our strategy, especially for manufacturing and for investment, is to make sure we're nimble and can pivot quickly between both ways of doing business. Right now, we have a percentage of our portfolio that is very specific. Right. That will not be a commodity because the requirements are so stringent. However, in the engineering side of the house, if we can design in a system architecture that can adapt to different requirements fairly quickly, and then you have a manufacturing system that reacts to that, right? And they're integrated. So you design for the factory designs upon engineering and vice. That's how you can do both and pivot quickly. That's what we're investing on.
Right. Okay. Well, so Ben, the question then turns to you, because you guys kind of are focused on this idea of an adaptive manufacturing process, right? Where design,
absolutely,
just like Anil's talking about, turns right into
if you had a mixed modular manufacturing, you could certify the process that he well outlined. Boy, you could move a lot faster at different classes of motors. And I think the other continuum that he's speaking to, which makes a lot of sense to me, is when you look at the continuum of weapons, it's been exquisite, and DoD will pay for that on occasion when they really need it, and then they've been looking for cheap mass, certainly counter drones and so forth, and SRMs being a commodity. The white whale, if I can use the Moby Dick analogy, has been the affordable precision mass. Mm-hmm. And industry hasn't done that historically well because it hasn't been affordable. So if we did have mixed module manufacturing where we could meet some of those needs, especially as many different weapon systems come online and they demand different sizes of motors, and we've got to move faster to qualify those, that's definitely the way we're going to have to move manufacturing-wise.
So Gordon, so what all this kind of is making it seem like is on the government side, you need to rethink like the iron triangle of program management to make it's all about time to deliver relevant capability and time to scale, and then those are the most important parameters, and then you're accepting a lot of performance changes just to get that timeliness.
Yeah, so we have a lot of the same, very similar philosophies in terms of the thought process relative to the processes and the products, generally, and we've got activities going on with 3D manufacturing ourselves, and we have that same trade conversation of the rapid development, how do I get quickly to qual,
right.
But how do I produce something from an affordable standpoint rapidly and at the quantities that the warfighters need? So we think about things in sort of this triangle of, can I get to a qualified process / facility?
Right.
Do I have a facility that I have confidence in the product that's going to come out of it? Independent of what the product looks like, do I have a qualified product?
Right.
And when I take that qualified product and I produce it at that qualified factory, can I show the consistent product that comes out the other end?
Right.
It takes all three of those to convince the warfighter that we've got a product that I can build in mass that's going to be able to serve the warfighter, that they're going to have the confidence in the quality, that it's going to work every single time. And what we see is there's different aspects of the capabilities that we stand up from an equipment, from a process standpoint, that contribute to each one of those. We leverage significantly more the additive manufacturing activities to get to a qualified factory, and we may build a few in that qualified factory through the additive manufacturing process, but in parallel, we're bringing up to speed and qualifying the more mass production processes that we have working in parallel, so that as soon as the warfighter needs it, we've got that proven for that particular product. So it's balancing the investments to be able to optimize across all of those. I need to be able to develop rapidly and qualify rapidly, but I also need to be able to build these things in mass very quickly.
Right.
And
So-
Brian, could I ask, just
Yep.
the one part of our report that's directly relevant to that point is that DoD needs to adapt and how it does its testing and evaluation and essentially qualification processes. So are you finding that industry is working really hard in that direction? Is DoD making that easier? Are you seeing changes and adaptations in that domain? Thanks.
Yeah, I'd be interested in all of your thoughts on how DoD is doing at adapting. It's changing the way it approaches test and evaluation, because they've made a lot of noise about TRMC, and those guys have talked about digitizing and bringing more, more the DOT&E forward into the development process itself. Yeah,
I think you got to be fair a little bit. I mean, like sitting here in the comfort of this room, not on right now, they're soldiers, sailors, putting it on the line, right? So having something safe to deploy to the fleet at scale is not easy. It's very easy in the Crystal Palace to be able to say a few things. So having said that, I do think DoD is trying. I do think the Hill is now getting very energized on this point, and I know the Senate in particular and the SASC is marking up, right, and they're moving. So there's a lot of energy around this issue. It is imperative that we solve it, right? And we've been letting perfect be the enemy of the good for too long, and you heard me say this in the green room earlier. RTX and ourselves have been looking at this through a lens of safety and performance. Safety sacrosanct, right? It's got to be soldier-proof, sailor-proof. We joked that I don't think you could ever achieve marine-proof. That's a different standard. Semper Fi. But having said that, that's where performance, you could make some trade-offs, and maybe there's some trade space there. And by the way, this mixed module manufacturing, if you could certify that, you definitely could go there a little faster. So just a few points.
Yeah, Gordon, I'd be interested in what you think of that, because you and L3 Harris, you guys have a lot of experience dealing with both the kind of historical approach to T&E and certification, and some of the changes that the DOT&E and TRMC people are trying to make in terms of bringing more of the test and evaluation forward and digitizing more of it, doing more through live and virtual constructive simulations.
Yeah, absolutely. And I know that we're all across the different industry players. If I speak specifically about solid rocket motors, and there's other things that we could talk about, but solid rocket motors, we're all having very similar conversations with the government and the different services about that concern. And also having conversations amongst the industry players in that product space of how do we collectively go in as a group to have that conversation with the larger government customer set and provide the data that's necessary for them to understand and believe that we're going to provide high quality, safe products out of this slightly modified paradigm. We're not jettisoning all of the decades of experience that we have, and there's lots and lots and lots of lessons that are learned over those 70, 80, 90, 100 years of experience producing these types of products. We do not want to have to go through that learning process again and do things and start from scratch in that regard. But we understand it's a change in the thought process. So there's a lot of work going on in a lot of different vantage points to achieve the level of confidence that we can deliver products high quality and safe at rate with this new paradigm.
Anna, what do you think? I mean, L3 Harris, or I guess Aerojet Rocketdyne, has been trying to, I'm sure, accelerate the T&E process.
And for us, we are in a unique position, right? Because it was L3 Harris, and then Aerojet Rocketdyne, and then the acquisition happened 2 years ago in 2 weeks. And L3 Harris traditionally is a very commercial company, right? So the value proposition was, hey, let's buy this asset called Aerojet Rocketdyne, extremely traditional, right? Which is the topic here. But we're very commercial, so what do we do with that, right? So that was the idea. And here we are 2 years later. I think that's the advantage right there, is how do we infuse the formerly very stiff SRM market or way of developing with all these other, the rest of the DNA of this company and do it more commercial. And that's where we are right now. I mean, that's the idea, which again, it goes back to working and partnering with DoD in this case, right? But I agree that the energy is there right now. And what I see is winds of change because of the international pressures, right? So nothing drives change like a crisis, right? I'm not going to say we're on a crisis, but there are crises in the world. And what I see is a customer-based, DoD inclusive, that is extremely receptive to change and listening to new ways of doing things that maybe 6 months ago wasn't there, 2 years ago wasn't there for sure.
So, Eric, I was going to ask you, I was saving you for last year because I was interested in, as a company that really kind of came at this from a completely commercial perspective, how are you approaching the test and evaluation and certification processes that the DoD wants to use? With a turbine engine, I assume it's different, and I assume you're, in some cases, plugging in to replace an existing turbine engine, so maybe that's not that hard.
So I think an absolute agreement that we have to maintain the focus on safety, on reliability for the warfighter. They have to trust when they push the button, send the thing, do the thing, that it protects the people it's supposed to be protecting. So absolutely need to have that there. I think driving towards flexibility on the requirement side so that we can push some of that variability over into the performance side, like you're saying, so that we have some room on the performance variability to drive some of the cost savings, some of the lead time savings. And then as far as, how do we test and evaluate that, obviously for us, there's going to be working with our integrators to close the loop on the entire system. But
so Tim, as the government, on the government side, were you finding that when you were doing the adaptive weapons programs like ERAM, were you having to kind of work with the warfighter or the operational community to talk with them about what kinds of performance changes or decrements or alterations might be necessary to get the weapons produced on the time or on the scale that they were looking for? So to basically square that circle of, you want it faster, okay, well, you're going to have to take some trades in terms of performance. Or if you want it at this kind of scale, we're probably going to have to accept some trades in performance because we can't afford, or we can't just build it at the scale you want, whether it's affordable or not.
That's right, absolutely. Discussions all the time. So, and very transparently, we're trying to hit a very particular cost point on a fixed price contract, which pressurizes industry to make certain decisions and give industry the ability to come back and say, I can trade off this performance if you're okay with that, and include the warfighter in that discussion. So if it's a performance trade that affects range, discussion needs to take place.
Right.
Are you willing to go 30 less miles and be okay with that? As long as you can achieve other desired effects on the battlefield, are you okay with a particular speed regime? Do I have some plus or minus in there? And I mean, those are very, very real discussions that, at least what I saw from the traditional A5 community and that force design kind of community, completely open up to, which was much different in my career early on, a little bit more stringent. I would say another area that it seems to be maybe making a turn is really inciting the decision makers with the modeling and sim information that you can get up front. An arbitrary number of test shots that's not fully empirically supported is fairly frustrating, but seems to be an adoption of I want to see more modeling and sim, and we've seen weapon systems that have been able to use that, both JASM, LRASM, JADM, all of these programs have been able to really show particular test agencies that it just burns down the risk and it ups the confidence level on safety, which is key. We have to like full bore that to the next level. And then I don't know, I would just add, there was a question earlier, and that's like, to me, what I've seen throughout my career, at least in the solid rocket motor area, is this, the mixture, what I call the batter. The mixture, the curing, the additives, the preservatives, all the things, and that becomes, it's highly customized. And it's kind of the secret sauce for a company. Imagine a world where you have if you want a flexible force, in my mind, you would certify a particular batter, a particular solid rocket motor that's a baseline use case that multiple companies can grab a hold to and have an agreement that in the business of a national calamity, we can test and show surgibility between multiple suppliers. So I call it the Waffle House batter that everybody likes. It's the stuff that everybody can actually use, and it's friendly enough for their tooling, it's friendly enough for the qual process, and it goes back to the qual process that you're talking about. Make that a part of the approved mechanism, and then you could potentially thwart, an uprising somewhere where you're like, hey, I actually need more arsenal, versus having stockpiled stuff. For that only has a shelf life of that's finite.
Right, and then the enemy gets a chance to vote, right? So you have to adapt, right? So if you stockpile a bunch of full up rounds, you never know if those are going to be useful or not, because the conditions could change and some new countermeasure could emerge.
You could use them if you told yourself, if the DoD told itself, I want to be operationally ready, so I'm going to use these in test exercises, and I want to exercise the operational readiness to show a variety of things, not just the engine, right?
But in terms of stockpiling for use in wartime, it seems like you're setting yourself up for a surprise in the case of obsolescence.
We've seen how that doesn't work.
Exactly, with like Ukraine and now Excalibur and everything else. Nadia, you want to ask about energetics here? Because I think one thing I was going to ask about here is to what degree you guys that build solid rocket motors depend on other people's secret sauce from the energetic perspective.
Well, for us,
and have any of those supply chains or some of the problems that have been identified now for 3 or 4 years, do you see shifts or changes in that domain?
I mean, I think Nadia just kind of touched on it. We realized very quickly we had to mix our own energetics, and we had to do that in order to be competitive to major primes if we were going to be a supplier. So we had to hit that straight on. Right. So we're doing that and doing that with vigor.
Right. And how about your supply chain that you draw upon? How robust
is
that? So you guys all drawing from the same precursor chemicals?
There are limits there, and you have to make some trade-offs. So the way we've approached it is the things we can't control, we are trying vigorously to do that and work very hard with our partners, Airjet Rocketdyne being one of them, so that we're not stressing the same suppliers to the extent that's possible.
Right. Yeah. What have you found, Gordon?
So maybe along those lines, you're asking, relative to the batter, those component parts, those raw materials that we use in the batter, in the propellant, the solid rocket propellant, those have generally, we have not found those to be terribly difficult. We're not stressing the supply chain from the standpoint of the raw materials, the raw chemicals that are used in those propellants. They're very readily available, very broadly available general chemicals. It's other aspects of the supply chain that are very unique to solid rocket motors that generally provide those choke points, like the very complex carbon phenolics that we use in nozzles and insulators, the thermal protection systems, composites that are used in cases and other things. It's those that we've had to target significantly to ensure that we've got enough supply chain, because there are so few suppliers out there that are doing that thing. And I know that we're all working on expanding that, and we spend an enormous amount of our time and investment in expanding those supply chains to ensure that we can keep up with things.
Is it the part itself, or is it the metallic or the alloys that go into it?
Depending on what particular component it is, it's one or the other. But there are very tight constraints from a supply chain standpoint in a few different things. Nozzles, you think nozzles, composites, cases, the thermal protection systems, as well as when we get into that mass production, and we've all kind of said, when we get into that large scale mass production, we haven't yet found one, certainly that solves all, a different technology like additive manufacturing that is better at the broad mass production. So do we have that mix and cast capability and capacity to be able to keep up with the quantities that the warfighters are going to need?
So Eric, have you found that as well when it comes to, because you mentioned Inconels and other alloys that you need?
Yeah, my supply chain is just diesel and air, so we have it a little bit easier than some.
Right, but I mean for the turbine itself.
No, yeah, the investment casting and super alloy supply chain is exceptionally challenging.
Okay, so is that an area where the government, or has the government made investments independently in these, kind of tier 2, tier 3 suppliers of alloys and metallic pieces that have to go into these engines?
Yeah, we're seeing all of the agencies actually providing grant dollars in that direction and working to help alleviate that.
And if I can add to that, so my business happens to also include the Center of Excellence for Northrop Grumman's air-breathing hypersonic propulsion systems. And so we have to use, in those, it's very different materials, very different supply chain from the solid rocket motor world, but we experience some of the exact same challenges and restrictions in those very, very exquisite materials and alloys that are used in those types of motors. And the good part of that, a good aspect of that is we've seen very willing and active reciprocal investment from the government to things that we've been doing from an investing standpoint to stand those capabilities up to grow the capacity in those areas.
Right. Same, and I've seen the same from the venture community as well.
Right. Are they making investments in building up the stockpiles of these individual parts, or is it more they're just building up production capacity so that you can draw upon that when you have a demand signal?
I've seen on the production capacity side.
Yep. Similar.
Right. Capacity.
I mean, for us, our hypersonic propulsion systems are 80% printed. That's when we've been, again, trying to come at it from a different angle. The thermal properties and the materials that you talk about with a vehicle, that's a different story, right? Because weird things happen above Mach 5, right? I mean, it gets pretty complicated, and that's some pretty heady material science.
Right. So one of the, I was going to ask you about this, and I think we had shared this earlier, but that hypersonic weapons seem like they might become sort of the go-to weapon in future warfights based on just their likely survivability.
Well, today we have no program of record for hypersonics today.
Right.
And I'll pause for effect because we don't have that on the target side, we don't have that on the offensive side, and we've been chasing it for a long time. So I'm going to overuse the white whale analogy again, but we've been chasing it for a while, and our adversaries clearly have it and are using it. So I would argue it's a strategic imperative for our country. Whether it's the weapon of the future or not, we could all sit here and debate. The simple fact of the matter is our adversaries have it, and we don't. Now, it may be technology that we developed. Now, there's a lot of different ways you can go at it. Air breathing, boost glide, rocket propulsion. We've flown successfully hypersonically 3 times in the last year, and the Air Force just let us declassify some of the information, and I can't talk about all the details, but it is achievable, and it's achievable at a relatively modest cost. Propulsion's typically about 1/3 of the cost of an all-around, give or take. And so that precision, affordable mass at a hypersonic level is within our reach more than it's ever been.
So, Tim, when we look at hypersonic weapons, and a lot of the modeling and simulation, the wargaming we've done sort of suggests that if you don't have a big pile of hypersonic weapons, you're going to find yourself at the losing end of a confrontation if it turns into a fires competition. Can we have modular? I mean, we're talking about here, Ben's talking about modular, scalable, relatively affordable hypersonic weapons?
I think the answer to that is yes. And I don't think I'm being aspirational about that. I think it's within reach, and I think there's companies out there that just like or some major, there's other companies also that are demonstrating this in unique areas of the United States. We have to take advantage of, right, there's a test range aspect to this that we need to be able to go in particular areas and show this. And this also draws back to bringing users and bringing other suppliers out to see these things so that they see themselves within the supply ecosystem of supporting that capability. I am not being aspirational when I say that can it be modular? Absolutely, because from an engine propulsion perspective and from all the other payload aspects that you have to put on a hypersonic weapon. We are at a losing advantage. We're at an extreme disadvantage.
Right.
Losing might be hard for me to say.
Right.
So maybe along those lines, and I was lucky to have Colonel Furman and a number of folks from his team out to the Elkton site earlier this year. We've got what we hope will be the first production air-breathing hypersonic weapon with HACM being produced at that site. And it's been a fantastic partnership, both with Raytheon as the prime and us as the propulsion supplier for both the booster and the air-breathing motor, the air-breathing scramjet that powers the cruiser for HACM. But there is a recognition that no particular technology or solution is going to solve all of the world's problems. So I know that there's a number that are out there. We happen to be able to be involved with the Aero program and be the qualified supplier for the solid rocket motor for the Aero program, which has obviously gotten a big boost in the last few weeks as well. So I think there's a lot of trial and data collection going on now across all of the users, both the supply side and the end customers, the flights that are going on, and all the testing and data that we're collecting right now to understand what is that mixture that we need and what is the mixture of technologies. I can say, and this sort of points back to the conversation that we were having earlier, we've been able to benefit, certainly in my business, it sounds like in the Ursa Major business as well, a lot from some of those advanced technologies like additive manufacturing, which are, I don't know, we haven't done the percentage, but it's probably pretty close to 80% additively manufactured products when it comes to air-breathing hypersonic propulsion systems. So that allows us an enormous amount of flexibility to do that rapid development for changes in mission profiles and things like that the customers need to come back to us with.
Or that you find are necessary to be able to get to the scale you're looking for, right?
Absolutely.
And I'll add one quick thing. I mean, we talk about safety. Unmanned, uncrewed air and sea assets are coming. I mean, it's coming, right? It's a certitude. And we talk about liquids on ships, and people don't like fires on ships. That's a bad thing in the Navy. It's a bad day. I get that. But there are differently applications where we could rapidly look at certification through a different lens if we're willing to with these types of weapons, if we're investing that kind of.
Yes, Eric, I was going to ask you, the hypersonic weapons argument is partly about their just survivability because they go so fast, and partly it's about range because in a lot of cases they're just really long-range weapons. Are you guys looking at, in terms of turbine engines, how do you stretch the range of a turbine engine out to get even longer and longer ranges out of those weapons so that you can get the kind of standoff that makes them comparable to what you might get out of a hypersonic weapon?
To be honest, I don't think we're actually looking at that aspect of the problem at Wayland. We're really pursuing the mass side of it, so we're going to be more on the subsonic, 100 to 300 to 400.
Oh no, right, but I mean, so I was just thinking about, are you trying to stretch the range through efficiencies, or trying to get to something more than like 500 miles so that you can?
Probably not looking at that far, but yeah, I think just through engineering excellence, just
Right, but to get to that, so is a thought process that maybe these 300 to 500 mile weapons might be getting launched by something that's uncrewed, so maybe it's not as is attritable.
Yeah, I think you're going to see some of the unmanned Group 5. I think you'll see USVs. You'll see a lot of these types of things. I think delivering a lot of those relatively shorter range mass weapons versus needing to fly the entire 2,000 or 2,500 miles.
Right, that makes sense. So, Anna, I was going to ask you about, you guys build, I think, the solid rocket motors for a lot of air defense weapons. So, obviously, high priority, lots of them being used right now in combat, both in the Middle East as well as in Ukraine. So, are you looking to try, is your efforts in improving manufacturing, including additive manufacturing design, to try to get to the scale that all these customers are demanding? Because I'm sure you basically have an order book that is a mile long.
Yeah, so that's a good example, right, of where we're adapting. Yeah, many of these programs are production programs.
Right.
So we're increasing production on programs that we either produced in the past, recent past, or we're producing today. It's just a matter of scaling. The engineering, the new engineering is going into, okay, if we have to scale capacity, supply chain included, how do we do it differently this time so it's not a by-product or by-program fashion?
Right.
So we're investing a lot on how to do it modularly. So, for example, back to the batter, I can do some levels of the mix that are fairly generic, right? And then customize down the road. But I can start from economies of scale, right? We are playing with that successfully. We're also going to the supply base with the same philosophy. And hey, we want to buy from you more, but not just for that program, it's probably for different programs. So you have to give me a different way where it's more modular. And we have a strategy around that, and the supplier partners are part of that. So even when with production programs that are tenured or seasoned, the manufacturing will be different in a few years because we want to do it more scalable.
So like horizontally going across multiple product lines and saying, I'm going to use the same processor and
that's exactly right.
Now, do you have to work with the government to get them to buy off on?
Many times.
Because I'm sure they've got some bespoke thing that came out of some decades old program that never really was adapted, and so you're having
every program has those, right? So again, commercial mind or mindset here, for the most part, yes. However, there are certain programs where we have now we have the IP or we own the licensing of the program. We have more flexibility on those. As long as I meet your requirements, Mr. Government. If I prove it to you with testing that I did it differently, but it meets your requirement, can you back off a little bit? And we lose some of those, but we win some.
Brian, could I?
Yeah, I was just going to turn to you. Yeah. Go ahead.
Yeah, on the point on allies. So I wanted to bring in a little bit of allies. I mean, I know all the representatives are U.S. companies, but then I was reading a little bit that URSO is involved in a new arrangement with our Japanese allies in the space transportation domain. So as our allies think about improving their defense capabilities, it seems like there's a lot. If they're not completely starting from scratch. Don't want to offend anyone, but they need to surge. How much can they learn from these conversations? Are those conversations taking place? Are there opportunities there? Thanks.
Yeah, well, they're absolutely there. And Nadia, thank you for the question and the lead-in. So we have the first approved export license for some rocket technology this last year. The Missile Technology Control Regime, MTCR, hasn't been updated in a generation. And it hadn't even contemplated the type of export we're talking about in some of these things. We have a vested interest in Japan and Australia in particular, in the Pacific, to develop defensive capabilities and to be on the proverbial front lines. So the Japanese have been leaning in. Now this is commercial space applications, but it was a first step. We were just out in Japan meeting with the ambassador, and it was the first trade mission of this administration, and we had a lot of meetings with the Japanese Parliament and Japanese Ministry of Defense. I think the will is there. I think we're seeing maybe a sea change. There's lots of activity on the Hill about FMS. You probably read about that even this morning. There was quite a few articles about it. We're going to have to think differently, and this is going to push the comfort level. You're talking about export of rocket technology. We need them to develop some of these capabilities. We need them to have hypersonic defense capabilities. We're at the forefront of that. We're going to have to move a lot faster, that's for sure.
So I'll open it up to if there's anybody in the audience that has a question here in a minute. But one thing I wanted to ask about, Eric, in terms of allies, I don't know if Wayland Industries has talked with allies at all, but obviously companies like Kongsberg, make subsonic weapons that require turbine engines. The Scalp missile and the other missiles. There's a bunch of missiles that are made overseas that use turbine engines. Have you talked at all with some of these foreign companies that might be opportunities to expand your scale?
It just started to, yeah. As we see Europe especially starting to scramble their military building, I think that things like propulsion systems and warheads and et cetera, those will be the things they want to try and get from us so they can rapidly develop systems around those. And I think we'll see their scale of their propulsion and some of the other systems trail those by quite a bit. So, but yeah, I started speaking to colleagues mostly in the UK.
Okay, good. All right, so questions from the audience, are there any? Oh, yes, yeah, thank you.
Hi, thanks very much. Elliot Pence with Supply Energetics. You want me to stand up?
Yeah.
Okay.
And say who you are.
Elliot Pence with Supply Energetics. There was a mixed review on the energetics answer. Somebody said it's not a problem. Another said it is a problem. Kind of curious to get a kind of more complex or denser answer there. Thanks.
Right. Yeah. So, what do you think, Anel?
Yeah. It's a mixed bag. That's why you got a mixed answer, I think. I think we agreed in terms of some of the components, energetic components and inerts that feed into energetics manufacturing, like nozzles and cases. Yeah, that's a choke point. So we're augmenting that. At the same time, in the chemistry itself, I don't think, like Northrop, there are times where we have, some constraints, but that doesn't limit my ability to produce at scale today.
I agree. I'll just add this, though, where you mix this stuff, you need to have lots of standoff. That means very rural areas, right? So you need very good chemical experts in very rural areas. You got to find talent, you got to find engineers very, very willing to live in very rural areas. We've just invested in 400 acres where we can mix our own energetics, and we have to have people willing to work out there and so forth. So that's kind of a limb fact that we haven't even talked about in terms of talent, but I agree with everything else that's been said.
Yeah, which is a good point, I think, to talk about workforce. So to what degree, I mean, I guess Eric, you mentioned it, that you need really specialized engineers to be able to work with some of the materials that you're looking to work with. Or just turbine engines in general. I mean, there's a limited pool of people that are able to do that. How difficult has that been to source? And do you need to invest in basically the educational process to create these engineers or technicians that are going to come then work for you?
At the stage we're at, we're really looking to hire some experience, and so that's actually the reason we're in Southern California, is to draw upon the tremendous pool of turbo machinery engineer that SpaceX has provided. Yeah,
absolutely.
Brian, we've seen an exodus of that talent, that propulsion talent leave government just over the years, normal demographics. So to regrow that talent that can sit side saddle, understand, communicate, advocate, that's been, we're suffering from the same talent challenge, and we're not in rural areas. We're in like really nice areas, and it's like, hey, this is something that we're struggling with. That is a very niche, propulsion is a very niche area within weapons. So when you find someone, you tend to try to hold on to them.
Right. Well, so do you have to grow them yourself? I mean, for Aerojet Rocketdyne and for Northrop, it seems like you guys have been doing this for a long time. So has that been the case?
That's a huge investment. I mean, people first, right? Mission always, we say that a lot. And without the people, I mean, we have a lot of technology and whatnot, but there is always people behind that, right? And again, this is a manufacturing heavy business, so you got to have a lot of labor. We go for that separation, from a safety perspective, but at the same time looking for an able workforce. But when it comes to engineering, it's very niche. So gotta find out a lot of partnership with universities. We do recruiting, and that's another problem. We recruit from ourselves. Again, when it gets very specialized, people with experience always have a job, but you're moving from one company to the next. So that's another topic on its own.
Right.
But that's out there.
The poaching of talent.
That's
yes,
right.
it's a long-standing defense tradition. Gordon, what is your perspective on that?
So similar to the conversations that we've had, obviously there is limited workforce. We spend an exorbitant amount of our time, and I'm sure that everybody does, ensuring that the incentives are there, the experience is there, the culture is there, so that folks don't want to leave because we're putting more money than I could probably calculate into the investment of making sure that our workforce has all of the experience that they need, that we're going to be able to continue to produce the product at the rate and with the agility that the warfighters need. It comes with a lot of, especially over the course of the last couple of years, where there's been this significant growth in the demand. Yeah. Obviously, some entrants coming into the solid rocket motor world as well, and propulsion world as well. So that adds to the competition. Yeah. It puts more dependence upon the experience that the employees have, not just the work that they're doing, but the experience that they have, the culture that they're seeing in the workforce and things like that, and it's something we take a lot of pride in.
Hey, so other questions before we, yes?
Hi, I'm Jessica Steffens. I work for American Defense International, but I came from the House Foreign Affairs Committee, spoke with Ursa Major when it came to MTCR. So thanks for talking about MTCR.
Thank
That's
you.
coming up again. I came from the international sales sort of space, and one of the major issues was the certainty. So a lot of the deliveries were delayed and backed up because there were certain component parts, often the products that you guys make, that was at issue. So there's this constant uncertainty. Will these foreign military sales cases come to fruition? And one area where I think we had worked previously, and I think is coming to light, is Representative Adderholt has a Special Defense Acquisition Fund amendment so that it increases the fund to sort of purchase in advance for foreign military sales. I was wondering if you could speak to what it means domestically for that certainty question, as we've got a lot more VCs coming in and putting up their own capital, and this demand is increasing, but there's still a lot of uncertainty we've seen recently just with this FY26 NDAA and the BBB bill. There's just that lack of certainty. So how is that impacting you as industry, but also how is DoD addressing that matter? Thanks.
I'll address the VC funding, because we're privately funded. I think it's a great question. I'll just hit that first. There's not some magical pot of private money out there, and there are some startups that have been very well endowed by billionaires. We don't have one on our staff yet. Thank you. However, here's how I'd look at it. Money buys speed and scale. Risk can be bought down with certitude. If I know there's a ramp, I can take a lot more risk. And I'm willing to do that, and I'm willing to adapt, and I'm willing to be agile. So that's the one way I would think of when it comes to private sector money, and I think that's an important part of the answer. There's other parts to this, though.
Yeah, the only thing...
Yeah, but for publicly funded companies, yeah.
Yeah, I would only add that from the standpoint of the customer community, and I'll say it's primarily the U.S. customer community, but end item customer community, but it includes what we should and expect from foreign military sales. That understanding of the demand profile is probably the single most influential thing that could help us with our business. And as we drive into conversations, we've been having conversations somewhat around kind of catalog parts. You can have catalog recipes for batches. You can have catalog size, propulsion systems that are interchangeable. You understand what the performance is. But we need to couple that with some compilation from the customer community writ large of, we expect to need 5,000 of this particular motor, or we expect to need 1 million pounds of this batch of propellant, this type of propellant. That kind of information, that demand forecasting accuracy and confidence, allows industry to go out, invest in advance, do research in advance, and have conversations with all of the customer communities to sort of set the expectations well ahead of time, way before the RFP shows up.
Totally agree.
Yeah, from a DoD perspective, you asked that as well, or at least from, I'll just say, Tim Furman's point of view, that knowing that is advocated for, and that you have a level of certainty and predictability and future cash, certainly turns on a program office a different way. when you know that availability is coming, especially from either an ally partner that was really interested in the product line and they want to get involved with the investment, it allows program managers and contract officers to do and build contracts in ways that are unique and that I think are more attractive for industry. So that's certainly one aspect of it. If I was king for a day, I would probably, if I knew that the money was big enough, I would throw it at probably the largest risks within the propulsion arena. And I would seek to bring multiple partners online that could help build. If it was all up, kind of all up engines or all up motors, I would seek to try to dub one as a lead and two that I want to keep warm. I'm not getting into quantities here, but if it was big enough, that's how I would design a contract. And that I would try to rotate that so that the industrial base is warm enough and that someone can always be a lead. Because you got to think, Representative Outerhold is going to help out or potentially, and then you might have an ally that says, hey, I like that. I want to join forces with that. And that's what we saw with, we saw a little bit of that with ERAM. Right. Quite frankly, we saw some opportunity that the DoD was doing. And so foreign partners were like, hey, well, I would like to get involved with that. I see you putting your money up. I want to put up money and get lift there.
Right.
Yeah.
Yeah, and then there's opportunities there because it's modular that allies you can deal with.
Can quickly adapt if you're willing to share designs and you're willing to do that in a non-disclosure agreement way, then I think there's opportunity space for suppliers to be able to help each other out in ways that are thought about but not acted upon.
Modularization makes that possible.
It does.
And I'll just add this real quick because this came up in Japan. It's kind of fascinating. When you talk about additive, you're talking about a digital file. And when you think about offsets and think about export, think about that for a second. You could export 80% of your design and they could print it on a machine, or you could control that percentage down to a finite. I mean, it really changes the paradigm on offsets and so forth. It opens up possibilities.
Yeah, that's a good point. From your guys' perspective, I guess it's similar lessons in terms of the value of certainty in terms of making the investments.
And it was well said, right? Money buys you agility. I really like that one. But it's the certainty and how, for public companies at least, give me the certainty. Like for example, right now in this environment, we're asking for letters of intent. Yeah. No money. Right. We're just asking for, hey, tell me you really want 5,000 of this. Right. And I kind of think of it as a one-way door or two-way door, right? Is it really a one-way door or not, right? Can I open it back, right, once I go through it? But if you tell me, no, we will buy 5,000, we really want 15,000, but we will for sure buy 5,000, the money conversation gets easier. The investment conversation gets way easier.
So Eric, for you guys, you're just starting out. I mean, to what degree are you looking for a demand signal on the government side?
Maybe it's a little bit of a controversial opinion, but I think the standardization of parts to make them easier to make, or the stockpiling, or the setting aside money for this, I mean, all of these seems to be answers to the symptom of having excessive lead times and not being able to be agile in your demand. And I think the biggest way I'm looking actually to attack that with Wayland is just by being more efficient at how we make parts. If there's 6 weeks of takt time on a MAR turbine, why should it take 13 months to get?
Yeah.
And I think that the biggest way we're looking at that is actually just to kind of look within and say, if this is the situation the world has given us, we're just going to deal with that instead of just opining that other people can do these things to make our life better.
Right. Take it in your own hands. That's a good lesson for everybody. Well, thank you very much. I think we're out of time, but I think that was a good place to stop anyway. But yeah, thank you very much for our great panel. So first of all, thank you for Nadia to join us remotely from her undisclosed location. Thank you to Ben Nicholson, who is the Chief Growth Officer at Ursa Major, to Gordon Lopresti from Northrop Grumman, where he's a Director of Propulsion Systems and Controls. And Eric Hostetler, who is the CEO and founder of Wayland Industries, or Wayland Manufacturing.
That's correct, sir.
I got that wrong. And Tim Furman, who just left, is the Senior Material Leader for Adaptive Weapons over in PEO Weapons of the Air Force. And to Anil Crespo, Vice President from Rocketdyne and L3 Harris. So gentlemen, thank you very much. Nadia, thank you very much. And thank you all for being here. Appreciate your time.
Thanks.
Thanks so much.